let's look at 9.3, which is scientific notation. So scientific notation is just a way to write really big numbers with lots of zeros in a compact form so that you're able to multiply and divide them using exponent rules. So when you have a really big number, say you're an astronomer and you're dealing with distance, to stars and stuff like that, you don't want to have to write 27 zeros on every number that you write. So you can write them in scientific notation, which is why it's called that, because most scientists use this. And so kind of the basis for scientific notation is you'll have one digit and then your decimal point and then any more non-zero digits. And then it's going to be times 10 to some exponent up here, where your exponent is positive for big numbers, negative for small numbers. Now that's not the mathematical definition. There's a math definition that talks about moving left or right and all that. But if you just think really big numbers, like don't we wish our bank account looked like this? That's a really big number, so that's a positive thing, a positive exponent. This is a tiny little number. That's a negative exponent or a negative thing. Just a silly little way to remember them. So let's look at this first one. So what I mean by one digit, your decimal, and then any non-zeros. So when we look at this one right here, here's the numbers that aren't zeros. So we're going to ignore these zeros down here. We're going to look at just these, and we're going to put the decimal place after the first one. So you always have one number and then the decimal point. So my answer here is going to be 3.967. We drop off all the zeros. That's what we're trying to get rid of. And then you're always going to have this times 10. And then to figure out what the exponent is here, you're going to count how many places you need to move a decimal. Now, when you have a whole number, they don't write a decimal, but it's assumed to be here at the end. So anytime you have a whole number, that decimal's at the end. So this exponent is going to be how many times I need to move it to get it to here. So I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So this would be a positive 9 because it's a really big number. Okay, let's look at this next one. Again, you're ignoring all the zeros. We're just going to look at the 8 and the 9, and we're going to put the decimal place after the first digit. So this becomes an 8.9 times 10. And now with decimals, you do have a decimal point here. So I need to count how far do I need to move it. 1, 2, 3, 4, 5 places. But this is going to be a -5 because that's a tiny little number. That's a decimal, so it has a negative. A whole big number is going to be positive. Let's look at this next one. Again, we're going to look at the non-zero digits and put the decimal after the first one. So this would be 5.623 times 10, and then we have to count. The decimal originates there, so we'd move it 1, 2, 3, 4, 5, 6. So it's a positive 6 there. This next one's the decimal. So again, we're just going to look at the 3 and 4, and we're going to put a decimal right between it. So this is a 3.4 times 10. And then here's our decimal. We'd move it 1, 2, 3, 4 times, but we're going to make it a -4 because it's a decimal or a tiny number. Okay, now let's look at it written the other way. This is in scientific notation, and they want you expanded out into regular form. So again, we're looking at whether it's a positive or a negative. A positive exponent means you want to make it a big number. So if you take 2.7 and you want to make it bigger, you're going to move it to the right. And so we're going to go 1, 2, 3, 4, 5, 6, 7, and we're going to add zeros in all of those spaces. And so when you go to write it, remember every 3 zeros, there's a comma. So this would be 27 million dollars. We wish it was dollars, right? But just 27 million. Okay, so you move it to the right because you want to make the number bigger. But with this one, it's negative, so I want to make the number smaller or make it a decimal, so I'm going to move it to the left 4 places. So it was 9.6. Now I'm going to move to the left 1, 2, 3, 4. Add my decimal and my 0. So this one is actually 0.00096. If you write the decimal on the big number, that's fine. You just don't have to on the big ones because you assume that it's at the end. So now let's look at why we want scientific numbers, because we can multiply and divide them quickly and in our head. Because remember, we just learned in 4.1 that when you multiply exponents, you really add them. So when you have this scientific number times this scientific number, you just multiply your big numbers. 3 times 2 is 6, and then you have your times 10. But when you multiply exponents, you really add them. So 10 to the 4th times 10 to the 3rd is 4 plus 3, or 7. So the nice thing about scientific numbers is you can multiply and divide them really quickly. So same thing, this one you just multiply let me write multiply down here. You multiply the regular numbers because parentheses mean to multiply. So 3 times 3 is 9. And then you have your times 10, and then you add the exponents. So -5 plus 4 is -1. So just remember, when you multiply exponents, you really add. Let's look at division. When you divide exponents, you really subtract. So you say 8 divided by 2 is 4, and then you have your times 10. You just got to be careful on your signs here, because what you've got is -7 minus -3, but 2 negatives make a positive, so it's really -7 plus 3, or -4. So if you've got a negative, you have to remember you subtract a negative, which makes it a positive. And then this last one, we're going to say 9 divided by 3 is 3, and then we have our times 10, and then we're going to subtract 5 minus 2 is 3. So that's scientific notation. So try the practice problems in 4.3.